Well, I don't know what happened, but I lost audio, so I don't know how long I was rambling on without any audio, but I'll have to edit that out. Just fast forward that part. But we're back, and I can see my audio input, so I think we're in good shape there. Weird. Oh well. Somehow we lost audio. I apologize for that. But we'll continue through and see what happens. I did yank on my cord pretty hard, so I don't know, maybe it screwed something up. It's one of the downfalls of having wires, but running on batteries has its disadvantages as well. So, alright, well, let's continue. We're on C20 right now. I have to see how long that audio is actually out for. If it was only out for a few minutes, I might just kind of fast forward that section of the video. C20 is 100 microfarad 50 volt. I wish when you were streaming or something it would actually give you an alert or say something like, hey, your video's not working. That is 35 volt. I need 25 volt. I've had a few cases where my internet dropped out and I didn't even know it. It looked like I was still streaming away, but actually nothing was being sent. So yeah, somebody needs to come up with a way to alert. Actually, this is 50 volts. 100 UF 50 volts. There we go. That's a little better. 100 microfarad 50 volts. Good. That is C20. If you were watching and I cut you off on the stream, I apologize for that, but it'd be really, I mean, it's boring just watching me put these in. It'd be really boring if you had to watch without any sound. I mean, I don't know, I guess you could put some music on or something in the background, but not that I'm entertaining, but I guess it still is nice to have a little bit of an explanation about what's going on. This one is really fighting me tonight with getting these caps in behind this transformer. That's usually not too big of an issue, but this one's fighting me. I'm surprised that this amp doesn't have any glue on it either. Usually when you're working on these, at least in this section over here, these caps are all like smothered with silicone and glue, so that must have been some other, change that was done along the way. And I don't see any residue, so it wasn't peeled off or, changed in any way. I don't know. This must be a one of the last revisions that they released before they discontinued these. They kind of worked all the bugs out and said this is it. Alright, so we're halfway done with the input board. Still a long way to go. There are a lot of caps on these boards. We're at C32. These guys usually do go bad. 470/16. There's a now this one is there's two resistors on here. On some of them they'll just be a voltage regulator or a transistor right here. So this is a little bit different. I don't know how hot these get, but these caps are usually another area where you want to have a look and check out. Like if you got buzz and hum. I still, like I said, I recommend replacing everything, but if you want to do the bare minimum, that's where I would start. All the caps that are by the main power supplies. Again, on all these, the stripes face me. Make sure that your polarities are right. It's always a pain when you get, you know, most of the way through a repair, or all the way through a repair, and one cap is put in backwards. These are another set of pack comms. I gotta look that up. I'm kind of curious now. I've never heard of PACCOM. It's gotta be some weird off-brand. I apologize, the view isn't that great, but this is the easiest way to work on the board, is having it stand up. You kind of get a little action of the solder sucker and kind of see what I'm doing. I need like stereoscopic view. I need like a camera coming in from both sides, a camera from the top, and a way that whoever's watching can just kind of float around the space and look at whatever they want to look at. That would be cool. Somebody needs to invent that. I should invent that. I am running low on 25 volt caps. 470. I think I only have one left. I do. That's not good. I have to add those to my order list. I'm actually going to do that right now because I will definitely forget. I'm terrible at remembering things like this. And that sucks because I just placed a DigiKey order this morning. Getting nicked for shipping again. I go through a ton of caps though. No matter what you do, you like anything that I work on, I always end up finding some weird random bad cap value in there. Then I gotta special order it. One of the guys I work with, his ignition module in his lawn tractor went bad and took it apart, and sure enough all the caps were old and leaking. And they were ridiculous values. 25 volt, 470 microfarad. And I stick with the UPS whenever I can. UPS series is probably my favorite cap now. And they have some in stock, which is good. Always buy bulk caps if you can. Don't buy them on that cut tape. Cut tape sucks. Alright. I'm sorry for the little delay there, but if I didn't do that, I'd forget, and then I'm going to go work on one in a few days, and I'll be out of caps, and then I'll have to set it aside. Be generous with your solder on these too when you're putting them in, because these are only single-sided boards. Actually, they're double-sided, but your mechanical connection for them is only really on the bottom side. So make sure you have nice fillets on your replacement caps. Alright, going down. I still do not see a bipolar. This guy does not want to come out. Sometimes when you're working with the larger ground planes, they'll fight you a little bit. It helps if you can get into the back of the cap and kind of shake it a little bit while you're trying to suck the solder out. Alright, 1 microfarad 50 volt polarized. Getting closer, but we're still not there. Double check your values too, just for the heck of it, because I do catch myself making mistakes. Alright, we're 3/4 of the way through this board. And we're going to get to the bottom, and I'm actually going to measure the values on some of those when we pull them out, just to see if that's the source of our hum, and usually it is. The auxiliary power supply filter caps are always a problem. The resistors, they have, you know, space on the plate. They could have put voltage regulators. They could have moved the resistors to the other side of the board. I mean, there's so many different things they could have done to keep those caps from baking. I don't understand why they didn't go that route. Sometimes you got to add a little bit of clean solder on these things to get them to actually break loose. I definitely dropped something, probably one of the caps. Alright, we found our first bipolar. First bipolar is going to be C33, and I'm going to look at my list and verify that C33 is in fact, yeah, okay, so that's bipolar on this guy, 1 microfarad bipolar. Now I also list that on another amp that I worked on, the signature, it was polarized. So that's interesting, but on this guy it's non-polarized. So that's C33. I'm also showing that I have C27. I don't think I've gotten to 27 yet. Okay, so C27 on this amp is a film cap. C27 on my list is a 0.47 bipolar. So that's interesting. So there are some variations between these. This is a second or third, or it's a different revision. Something about the way that this one was set up is different, but we're going to take or put back in what was taken out of it. So if I pull out a 1 micro bipolar, a 1 micro bipolar is going in there. I don't know enough you know, about these to upgrade them, I guess you would call it, turn it into the larger counterpart. Not that you'd need it though. I mean, I had a Super Junior in my living room, and I was watching Looney Tunes one time, and Elmer Fudd fired his shotgun, and in the little 8-inch Super Junior, that subwoofer hit so hard I really thought somebody shot the shotgun right outside my window. It was incredible how much, you know, a tiny little amp and a little subwoofer could put out. It scared the hell out of me, I'm not gonna lie. So I can only imagine it's 10-inch bigger. 2 of these big, you know, 10 inches. Watching movies is going to be a whole new experience. I understand why people like these things so much. I mean, they pack a punch, that's for sure. Be careful with your little transformer wires here. You don't want to bend or break them. I mean, I guess you can bend them, you don't want to break them. I grabbed the wrong cap there. This was a 1 microfarad bipolar. See? That's why you gotta double check your work, because I totally just made a mistake right there. C33, yeah, C33 is a 1 micro. The one that I put in is a 0.47, so that fell out of its spot in the bin. That's one of the problems with having so many caps. You have to use the like dividers in the bin. Sometimes they get a little mixed up, so double, triple, quadruple, however many times you need to check your work to make sure you're getting the right parts in there. I'm sure it would probably work with that value in there, but I mean, who knows what it would change. It might change the crossover frequency. It might change. I don't know what part of the circuit that's in. I just know that that's where the cap goes. And I've never been ambitious enough to make a full schematic of this board. Especially when I know they're out there somewhere. Somebody's got this input board schematic. Just a matter of time when somebody leaks it online so everybody else can actually use it. But these, I mean, these speakers are old by now. I mean, they should be available. I think when any product is discontinued, the service documents for that product should be released. Like, they're not going to make it anymore. The company's not going to profit off of it anymore. Generally, nobody does component level repair anymore. So why not release the schematics? Like, you literally have nothing to lose. Somebody's going to duplicate your product and resell it? Okay, well, I mean, if they wanted to do that, they could just buy one and reverse engineer it. So you're not really losing a whole lot. I don't know. It's annoying that I can't find the information I need to perform some repairs. If you guys follow some of the other repair people on YouTube, you know, right to repair is a pretty big movement right now. A lot of people are getting involved, and I don't blame them. Like, you know, if there was something I could do to be a part of that, I would, because you know, I like to fix my broken things. I don't like throwing stuff in the garbage, especially if it's, you know, valuable. Like, I have 5 LG LED video projectors, 5 of them, and they were, you know, most of them were purchased on eBay. They're all broken. Some of them I can fix. It's usually the LED driver board that goes bad, but the problem is I can't find any of the other parts that I need for it. So they have an optics problem with those. By the way, don't ever buy an LG LED projector. Nobody. I do not recommend it. They use plastic optics for their lenses. And over time, the UV light from the LEDs, because yes, LEDs do emit some UV, damages the plastic optics, and they turn yellow, and then when they turn yellow, the LEDs form hot spots. They start to heat up, and then they further deteriorate, and eventually they either burn or they catch on fire. So, simple fix, all you have to do is pull the lens out, put a new lens in, and you're done. And it, you know, that lens probably costs $2 to make because they're made out of plastic. Can't get them, can't find them, have no idea who makes them, who the manufacturer is. LG won't give you any information, so over a $2.50 lens, I have to trash an entire projector. It's a terrible thing. If I really wanted to, I'm sure I could take it to a glass place, you know, that does lenses and have a custom lens ground. But it wouldn't be worth it. You know, you would pay probably more than the projector's worth to have the lenses made. It's a freaking shame. 22 microfarad, 50 volts, 4C35. So yeah, right to repair, I think, is an important thing. The ability to finding source parts is important. I'm looking at my 22 microfarads and they all seem to say 25 volts on them, but my box is marked 50, so I think I made a mistake on that. I'm going to have to sort those. I have some 50 volt ones in there. I'm going to have to re-go through that bin. So again, double check your parts before you put them in, because you will make mistakes like that too. And I don't know if there's 50 volts on this part of the circuit or not, but I definitely don't want to put a cap that's rated less than the manufacturer calls for. If they put a 50 volt in there, it's probably for a reason. And if it wasn't for a reason, well, I don't know, why or why not, so I can't deviate from their values. These two right here, that you can't see because these two right here point up. And the board's marked. There's a little plus on the board, but so we have a couple more to go. 1, 2, 3, 4. Yeah, I got 7 that I can get to. 2 that I have to pull these caps down here. So we're chugging along. And most of the rest of them are 4.7s. I'm definitely using the wrong tip on my solder sucker too. This is a number 3, I believe. Which I can't even no, it's a number 6. It's a good tip, but it's just a little too big for these tiny caps. 4.7, 50 volts. This is C12 that I'm working on right now. I think we're all done with the polarized. I don't believe the amp board has any non-polars on it. I'm sorry, I think we're done with the non-polarized. I'm probably going to turn this plate too. It's getting a little hard to reach around down in here. I'll tough it through these because I want to test these big ones on the bottom. I'm curious to see which ones are bad and which ones are good. We could just bend these leads out of the way. Try not to stab yourself. And definitely don't lean into the amp. I almost poked an eye out with one of those leads too one time. Best practice probably would be to trim them as you go. 4.750, and this is C11. But I'll give everybody a view of the bottom of the board as I get ready to rotate it. And give you a look at my solder joints. In case we have some eagle eyes out there, maybe they'll see something that's not right. I think this is just going to be a pretty straightforward cap replacement though. I did work on one of these that defeated me, and I recapped it, repaired everything on the board. Amp would come on, and only one side of the power supply was working. Couldn't figure it out. Looked over the whole board, couldn't find anything. Tested all the components on there. Ended up being a bad resistor. That was the problem, and another tech found it. But it took him some time too. So hopefully we don't run into anything like that tonight, because trying to find a bad resistor when there are all these like little tiny 5mm ones is going to be a nightmare. 100 microfarad, 25 volts. But I'm fairly sure that this is just going to be a simple recap. We'll get to the other. I'm definitely doing the other one tonight. I'm probably going to do it. I'll probably end this stream, take a little break, get some coffee, have a snack, and then I'll start. I'll just make it like a part 3 of this repair, because I think I'm pretty sure it's just a component fell off the board. I don't know how or why, or we'll be able to tell when we look at it if it was a manufacturing thing or something else. My desk is infested with flying ants right now. I don't know where they came from, but they're really annoying. Get out of here. They must have hatched right outside the window and they're all flying in right now. But it's pretty hot. It was a humid 85 degrees today. That's hot for me. I like Cleveland's colder weather. I don't like being cold, but I like the cold weather, if that makes sense. I'll take 75 and cloudy. I can be happy with that. 75 and sunny is brutal because the humidity spikes. Alright, 3 more. C40, and that one I did was C24, and that was a 4.7 at 50 volts. We got 2 more of those, and then one, actually 3 more, but the bottom 2 we won't get to until I pull those other caps. I've heard of some people having problems with the auto on off and standby circuits on these. If your auto geez, that's hard to say. If your auto on and off is not working, there's a little green capacitor right here. It's always that. Always that guy right there. So if you're having issues with that and you can't figure out, you know, why your sub isn't turning off or turning on or behaving, it's always the capacitor. Alright, so C39 and 36, 4.7, 50 volts. Check those two, make sure they're good. 4.7 and 50. These are the last 3. And then I'm going to flip this board. And I definitely did these in the wrong order, but that's okay. And I know I give this PSA in like all my repair videos. Do not bend the leads on the parts that you install. That's one thing that makes these amps actually nice to work on, is the leads for the caps are not they're not bent from the factory, so I can actually get the caps out pretty easy. All of the resistors are bent, so if you have to change resistors on here, it's a nightmare, especially since they're these small ones. I would rather cut them out than have to try and unsolder them. It's easier just to snip them and replace them. Alright, C40, 1 microfarad, 50 volts. That does it for the input board. Input board should be behaving like it was brand new. First, actually, it's going to behave better than brand new because they're higher quality caps. We just lowered the harmonic distortion by 1/1,000,000th of a percent by switching to better caps. So, alright. So now I flipped it, and there's 2 caps like way down in here, which you can't really get to unless you pull these guys out. So those are going to come out now. If my light will behave, I need a new light. Made in China. And I know I say that a lot, and it's nothing against China, it's just I don't, cheap stuff gets on my nerves. And I can't afford the expensive stuff because you pay, 5,000 times the price for it, and it's really not that much better than the cheap made stuff anyways. I guess it depends on what you're buying, but be careful when you're pulling these out, especially if you don't have a good solder sucker, because you will tear the pads off the board. This section gets hot. So these guys are prone to pad lifting. And if you tear a pad off of a through-hole part, you got to replace the whole through-hole. There's no other proper way to do it. All right, so let's check these 1000 microfarad ones first, and see if this is our source of hum. Use my fancy cheap LCR meter. Now this actually is a cheap meter, but it's a really good one. It has not failed me yet, and I read the reviews and bought it and tried it out, and it's been good to me. So right off the bat, first one we grabbed, I'm not getting any capacitance on. Well, there's problem number 1. That's one dead cap, and just to prove that the meter's working here, I'll grab this 470. And this is one of the other ones that's potentially bad, but let's see what it reads. So 377, so it's out of tolerance. And these are the ones that I was saying on the input board that you want to generally replace. Let's grab another one of these off the input board and check. I don't think my meter's that far out of whack, but could be. Here's another 470. That's reading 423, so that's a little bit closer. Again, these are the ones that generally you should replace, but let's get back to these power supply caps here. See if there's any good ones. So this is supposed to be 1000 microfarad. I'm reading 53. Bad. Junk. Let's try again. 1000 microfarad. Nothing. Completely dead. And our last one. 1000 microfarad. And I'm reading 1. Okay, we'll call it 1.5 because it jumped up to 2 for a second. But this is why this amp came to me, because it definitely has to have some hum in it and some other problems going on. Let's grab some good ones. I hope I have these. Yeah, I do. Okay, good. Let's grab some new ones and see what some new ones read. $9.89. That's within 20%. $9.90. That'll work. $9.82. $9.81.82. Good caps, bad caps. And the originals are, yeah, these are only 85C rated, and they're these surge brand, garbage brand. You can see the UPS has got a little more beef to it, a little more mass, so these are going to be better caps. So I'm going to pull out these other two. And let's see what these other guys read. Probably going to read failed. These are a little bit out of range for my capacitance meters. These are rated 2200. They're only 85C, so I can almost guarantee that. Well, this one I can tell is bad because it leaked out to the bottom. There's a little bit of electrolyte there, but let's see what it reads. So 715. That's way out of tolerance. Not completely dead, but out. This one also leaked. Let's see what this one reads. 490. So yeah, you're not getting good filtering when your caps are that shot. So these are 2200s at 25 volts. Yes. These are the new ones. Now, I couldn't go with the UPS on these because I had to stick with the can diameter. These are UHEs. They're 105C rated. UHE is also a good cap to use. Nichicon UHE. And you don't have to use Nichicon. You can really use any tier 1 brand that you want. These are the ones that I prefer to use. Like I said, I've done this a few times, and they work for me. So while I have those out, we're going to take out these two on the last two on the input board and swap them out, and then we'll start recapping the amp board. Amp board should not take as long. There's a lot less caps on there, but all three of these caps right here are prone to failure. You'll find that these leak too. So really, if you're going to repair your amp, you should just recap the whole thing. Take the time. I mean, if you don't, eventually they are going to leak. Like, I can see the electrolyte on the boards here. I got to get that cleaned up. That'll kill your board. You don't want leaking caps on your board. This is C3, and it's going to be 100 micro, 25 volts. Check our values, check our installation direction, and then there's one more 4.7 in there, which is C5. I'm just going to pull that one out to make this a little easier. I do like the bright yellow color of those caps, but that's about it. I don't really like anything else about them. Since this is kind of back in a hard to reach place, I'm trying to get it in there with the tweezers. If the leads bend when you put the cap in, I'll allow it. Like you can have those bent leads. But they're only V'd out. They're not folded over on top of the board. V'd out leads, I will say, are acceptable. One more 4.7 and the input board will be done. So I believe we found our problem. When I pull these three out over here, I'll put those under the meter too. And I'll put the two big ones in the back. There's two large 47s back there. We'll look at the big ones on the amp board and see how thermally stressed they were. Probably won't be as bad as the others because there's really no significant heat sources. These coils do get a little funky, but these ones actually look good. There's no like charring, no brown. Doesn't look like they got too hot. If your amp is blowing fuses, these are, I believe, 7 1/4 amp fuses. Do not put 10. Do not put 20 amp fuses in here just to see if that'll make your sub work again. It's not going to make it work. What's going to happen is when you put a 20 amp fuse in here, it's going to nuke your coils here, and that's a part that you can't get. So if you want to do some troubleshooting, do so the right way. Don't do it by just popping a fuse in and seeing what happens. I've had a couple of these amps come into me, and I don't know what value those coils are, so I can't reproduce them. I mean, I can get close, but I don't know what it's supposed to be. So I can just rewind the bobbin, if the bobbin even exists anymore. Usually it's so melted you can't even use it. But I've had to turn some amps away because those were too far melted, and there's nothing I can do. Alright, so input board is done at this point. I'm going to trim the leads. You don't have to, go crazy trimming them. Leave a little bit of wire on there, just so there's something to let the solder hold on to. You don't have to trim them flush to the board. But you want it to kind of look like it's a factory job too. A good set of nippers goes a long way. And I generally like to leave the legs on there because that tells me I've been through the entire board when I'm starting to cut leads. Sometimes I'll be working on a board and I'll forget one cap, or I'll have to order a cap, and if I trim all the leads off, it's real easy to overlook that and lose my my place on where I was working there. We're using leaded solder, so it should be a pretty robust joint on these. You can put a little bit of silicone on some of the larger caps, and I usually do that before I send it out. But the leaded solder just tends to hold up a lot better, and it's easier to work with. It's so much easier. So on the camera, when I'm done here, you might have a little bit of flux residue, but I highly doubt that, you'll be able to tell that anything was really done to this. And I don't, these things in good working order, they still command a decent price. I know I've sold a handful of Super Juniors, and they regularly sell for $500. these guys are probably twice the output of those. So it pays to maintain and work on your old gear. This stuff tends to hold its value if you take care of it and keep it in good shape. Especially after a fresh recap. All the audio nerds go crazy when they hear that. Like, just freshly serviced, brand new, I'll take it. Alright, almost done. Sometimes you gotta check these lines here. These little hard jumper wires that go from the input terminals. I have seen on a couple of occasions where those were not soldered in well at the factory. Those are hand soldered after the boards are installed. So, if you got your sub and it was built on a Friday, you might want to check your solder points just to make sure that it wasn't 10 minutes before end of shift and whoever was putting these things together wanted to get out of there and didn't care. That and these 4 solder joints here pays to go over those and have a look. So alright, we are done with that. Now it's time to start rebuilding the amp board. We're getting close. 60% maybe? 62. Check your polarities, make sure your polarities are good. Now, since these are 105C rated, they're definitely going to last longer and they should behave a little better when this amp gets hot. I don't think that they get anywhere near that temperature, but they do, bake by those resistors. On most of these, the pads are marked too. The square pads are positive, round pads are negative. So if there's no symbol on the board, you can find out what your polarity is sometimes by looking at the pads. Now, not all manufacturers follow that. Here's another thing I'm going to do. I'm going to take this resistor, pry it away from that cap. Same with the one on the other side. We're just going to push it away just a little bit. Not a lot. We're not going to fold it over sideways on the board. Just give it, 2 to 3 millimeters of clearance. That will greatly help in keeping these things cool. And that little bit of space, it will make a big difference. You'd be surprised. Because as the air's flowing around on the inside of this thing, the air is really not a very good conductor of heat. So any sort of little movement is gonna actually be amplified by that distance. So you'll get a lot better cooling just shifting those things over just a tiny little bit. The amp's definitely going to sound better and run better with functional caps in place. And as I said before, like this is generally your main go-to. If you want to do the cheap version of the repair, this is where you got to start. Don't quote me on that though. I'm sure I'll get a message at some point. You said this would fix my amp. No, that's not what I said. Start here. See what happens. You might get lucky. Alright, here we go. Those are in. Caffeine boost. It's definitely coffee time. Gotta try not to drink them sugar drinks, but every once in a while I need some. I'm gonna change my tip for this. I want to use the smaller tip. I'll show you my secret for changing tips on the fly. I turn the unit off. This is just regular tap water in a little pill bottle. Grab a pair of pliers. Quick dunk. And the tip comes right out. Well, the iron's still scorching hot. But that quick little dunk shrinks the tip. It allows me to do a change without losing too much heat in the whole iron. Pro tip, plus the flash boiling of the water actually cleans the tips. So it helps maintain the tips and it gives you a quick way to change them. So I'm at 580 C already. I'm sorry, 580 F. I can't put my Weller into Celsius. We'll let that heat up and then we'll get started pulling out these small caps. I'll probably have to change tips again when I get to the larger ones on this bottom section of the board, but I'm not too worried about that. Changing tips will make pulling out all these little caps easier, and there's a ton of these 4.7s in there. So we'll get through that, and then I'll leave the two main ones in. I'll probably replace the big tank caps off video. My stream just cut out. Alright, there we go. The computer's acting weird tonight. I'll leave the big ones in just so we can get through the test, and I don't know. Let's see what happens when we get there. Maybe I'll just do it all at once. Keep everybody up late with me. It's not too bad. I'm usually up a lot later than this. Some of these caps have large planes on the top side, so you got to get a decent amount of heat. These little ants keep buzzing around me. I'm going to get a hairspray bottle and turn it into a flamethrower. Alright, 47 microfarad, 50 volt. C10 is our standby power capacitor, to my knowledge. I could be wrong, but I'm pretty sure I think that's the guy. I'll pull that one out. That's actually a Japan cap too, so probably a good one. Let's see if this had standby issues. 10 microfarad, 35 volt, and it's a tiny little cap. I actually have to bend the leads. Let's see what we got. Power cycle. I don't know why I just showed the devil number on there, but alright. We're way high on the range here. Let's give it something a little more reasonable. So it's a little out of whack. Seven is not that great for a 10. Let's put a real 10 in there. We'll just give this one a measurement to compare it to our 7 that we saw. This one's 10.2, so definitely an improvement. So if this thing wasn't going in and out of standby, it's going to go in and out of standby now. Never understood why they use capacitors for standby circuits. That's kind of a mystery, but I'm not an electrical engineer, so I can't tell you why they do that. Somebody smarter than me will have to go in there and do that. So these two in the back are really hard to get to. So probably have to use the tweezers to get in there. Check our polarities. Come on, getting them out is the hard part. Getting them in isn't too bad. Tweezers really suck for grabbing things too. Alright, this is a different cap. This is the NRSA, whatever that is. 10 microfarad, 100 volt. I know I have some of those. That's a filter cap for something. Positive is, most of the positives on this board are facing up. Negatives are down. So again, pay attention to your polarities. This board is usually not too bad. Once you get all these weird ones that are hard to get to done, it goes fairly quick. And again, I'm not trimming the leads on these until I'm done with the whole board. That's kind of my sanity check. Again, some of these, it really helps if you can get in there and shake them around, wiggle them a little bit. $220, another PACCOM. I thought this was a different one, but nope. 220 at 25 volts, PACCOM. And that is polarized. I don't know why I looked, but 220 at 25. Positive facing up. The only other one that's really difficult to get to is this 47 that's buried behind everything. Alright, that one's in. The rest of them are pretty easy to get to. None of the film caps I've ever seen go bad. I've seen one of these large yellow ones actually like look like it blew up, like a chunk was blown out of it. But I think that was due to somebody messing around with either the fuses and putting a way overrated fuse in the system, or some sort of surge or lightning spike or some sort of really random event, because that's not a common thing. But I have seen it before, so I can't say they never go bad, but they usually don't fail under normal use. And even though these things are color coded, still check the values on them, because I've seen some where they'll do something sneaky and you'll find like all the 4.7s are yellow, and then you'll find like a .047 that's also yellow. So check your values. Don't get lazy and just make assumptions, because that's usually when it'll bite you. And if you're doing one by one and you don't have a cap map or anything to show you where these parts go, you'll be regretting that later. But for the most part, you know, they will all be the same, but there's always that one that's annoying. Alright, the hard ones, the ones that are hard to get to, are done. Now we're just gonna buzz through all these other little ones and fire the samp up. I don't know if I'm gonna do it through a speaker or into my dummy load. Either way, we'll get some we'll get the scope on there so we can show you what it looks like. And I'll probably use the cheap scope. I still can't get the good scope to show up in real time. And it's kind of not fun looking at a scope when it's all like choppy and doesn't really jive with what I'm trying to explain. Actually, I didn't check the value on this guy. 4.7, we're good. What I'm thinking about doing is cutting a hole in my table here, and underneath my mat putting the scope face up. And then my top camera will be able to see it. The other option is getting a small auxiliary webcam just to point at my scope. I haven't, you know, I've thought about doing it both ways. I haven't looked at webcams lately. I know, you know, during the start of COVID they were impossible to find. I assume you can probably get them now again. But it would be nice to show everybody on the good scope. And by good scope, I mean it's a Rigol DS1054, so decent, not like ultra high end. I do have a Tektronix scope, but I don't like using it that much. This one's got a better screen and a better picture, and it's newer. The Tech scope is good, but for most of the stuff that I do, it's just not needed. Alright, this is C3 right here. Sorry my head's in the way, but I couldn't see the holes there. The resistor was blocking it. Alright. I like to work from the bottom up too. It makes it a little easier to get through. So there's really not that much more to go on here. I'm skipping the large ones for now because I know my tip is too small to get to them and I don't want to change chips, so I'm going to do all these little ones first and then I'm going to come back. 4.750 volts. This is a different color surge, so there's a difference between these. These are 85C rated and they're 9814s. And these ones are 85C rated and they're 9927s. So we're gonna look up the data sheet and see what the heck the difference is between the two. Just because I'm morbidly curious why there's two different cap versions in here. Probably won't be able to find a data sheet, so I'll do that at the end of the video. That'll be like some bonus features. Like the extra junk on a DVD that nobody generally watches. interesting thing is it was right next to one of the other ones. And they're connected in parallel. So maybe they have different characteristics to them. Different ripple currents, or I don't know. Interesting. They are connected in parallel. I dropped a little solder booger in between those two. That's not good. Corrected. So 4.7, 50 volts. Again, double checking for errors, seeing if I'm making any mistakes. Now, one of the things I will do is if I do determine that the difference in these caps is actually needed, I'll do an update, and we will well, let me just see if I can find the data sheet. It's gonna bother me now. I shouldn't have said nothing. It's gonna drive me nuts. Surge capacitor 9927. Nothing. No data sheet. No. Let's just try surge capacitor. Surge components. Alright, so they do have a website. They're a global portal that's been around for 38 years. Bear with me, I'm looking this up really quick. Aluminum electrolytic. They have hybrid polymer, organic polymer, radial, screw-in, snap-in, surface mount. Let's try axial. Nope, that ain't gonna be it. Let's try hybrid polymer. No, not it. Organic polymer. Nope, not it. Radial. So none of these have number ratings on them. I don't know what a 9927 is. I'm guessing that the difference is going to be probably the leakage current between the two. But these things are probably so old the data sheets don't exist anymore. Surge components 9927. Yeah, I can't find anything on these things. I give up. I give up right now. Because it's not even remotely important. What is important is replacing them and putting good capacitors in there. And I know the general... Look at this. Here's a little factory screw up. Dang, I was praising this amp for how good it was, and now I gotta take a star off. Somebody dripped a big solder blob on this wire. That could have easily fell off and shorted onto the board somewhere. Never fails. It's probably another 4.750. So we'll say that the cheap capacitors have like a surge rating of like, or a ripple current rating of like 20. I'm just pulling this random number out of thin air. and the other version of that has a rating of 5. So we'll say that the Nichicon ones have a rating of 15, so 2 of those are probably equivalent, if not better than 2 of the cheap ones. That makes sense to me. Again, this is stuff you really need the schematic for. You know, is it an ultra low ESR capacitor? Is it, you know, I don't know. I don't know what it is supposed to be, because that information is not provided. .750 volts. Make sure our polarity's good. Make sure we got the right parts. And this bottom board, like I said, the actual amp board goes way faster than the top board. Alright, we got one hiding here. I know this is a different value. I know that because I remember. This one is 47. There's 2 of those. Again, make sure you discharge this amp before you're working in this section, because you can get nailed pretty good. 47 at 25 volts. 47 at 25. Make sure our polarity is right. Make sure it's in there and standing up straight. Doesn't have to be perfect. But make sure it looks nice. Alright, C6 is another 4.7. That's this guy here. .750 volts. A lot of capacitors in these things. Somebody put some time into making sure that everything was properly filtered. Probably spent months on this design, and then they shipped the design away and they ruined it with cheap parts. Poor guy. Moderately funny. Solder sucker's getting a little clogged up. Yeah, we gotta take a quick little break here and declog my solder sucker. Best way to do that is to find a cap with the right size leg and jam it in there. Because the tip cleaners that they sell you aren't worth a damn. That's better. Not perfect, but better. The filter on the bottom probably needs to be replaced. Alright, let's this is one of those caps we were gonna test. This is 470 at 25 volts. Yeah, the 390 is not good. It's, you know, almost 100 microfarad off. So you can see why I always recommend just doing the whole thing. And this is my last one. And I have a feeling I'm going to need 2 more. I think the other ones might be 16. I don't know. I don't remember. I'm going to be disappointed if I don't have enough to finish this guy out. I'll go look around. I might have a couple in one of my other boxes. I know I ordered some parts, so it'd be nice to get through an entire amp repair without having to go for a part 2 for a change. Alright, C16. 4.7 at 50 volts. These SUNFIRE amps chew through these 4.7s. I have to order them in quantities of 200 when I started working on these amps. Ooh, something had a little charge to it. I did drain these. Let's have a look at that there. .2 volts. Millivolts. 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 I don't know what the heck would charge that back up. It's not plugged in. Okay, this one has 4 volts on it. Oh. Sometimes after you drain them, they do creep back up, and you know, you can get a 10 or 15 volt float charge back on them, and that's enough to scare the shit out of you. So pay attention to that. Just be aware. But like I said, everything on here was pre-drained. Okay, good. These two are 16 volts, so I will have enough caps to do this without having to dig for any more. 470, 16. Let's measure this one too. See how out of tolerance this one is. So this one's actually good. So the 470 25 volt guy, no good. 470 16 volt, good. And I don't want to say no good. I mean, it's just way out of tolerance. You know, it's 100 microfarad off, roughly. It would still probably do its job, but just not as well. And I know I have 16 volts. So we'll grab 2 of them. I have to look at my little yeah, it put a little blister on my solder there. Burned it a little bit. Can kind of see it. I don't know, probably 20 volts in there, if I had to guess. But I guess a good real life, you know, test is, you know, to show that these things do hold voltage. So imagine if that was fully charged. It would have been a bad day. I mean, I don't know. I don't want to say it definitely would have been a bad day, but it definitely would have sent solder probably flying everywhere because it would have blew that, you know, blew that wire apart. So just be careful. And keep in mind that, you know, caps can actually charge themselves back up from static electricity. That is a thing. So even after you discharge them, they could still have some residual charge left in them, or they could develop some residual charge. And these have no bleeders on them. There's nothing to bleed these two guys off. When they charge up and you pull the plug out, they stay charged for a very, very long time. Discharge them into a 100-watt light bulb. That's generally what I do. These darn little flying ants are driving me nuts. They don't seem to like the soldering iron too much, though. Alright, we have 1, 2, 3, 4 more caps and we're done. We have this 4.7 here. Which I think is a 4.7. We'll double check. Yeah, 4.7, 50 volts. A little piece of solder actually broke off. Alright, we have our other 47, which is hiding down here. And this is this red line here is our main power end. Red and white, these are our voltage rails. And that's plus and minus 160 volts, roughly. 170, 160. So there's some juice that travels on them wires. Not a lot of current. You don't need a lot of current. The current comes from your inductors. But you don't need a lot of current when you're pushing high voltage into the driver. You can get away with using a lot less current when you bump the voltage up. Same amount of watts going to it, just it's a pretty smart way of doing it. You're just using line voltage, turning it into DC, and it's giving you two pretty stout rails to work off of. And you switch the higher voltage to the speaker, and you don't need you know, transformers, and you don't need a large amount of current going to it to deliver the same output power. Alright, 4.7, or I'm sorry, 47, 50 volts. I'm wondering why this one is so much bigger than my other ones. That's because it's 25 volts. See, I'm not paying attention. It's late and I need my coffee. Alright. 47.25, 47.25. We're good. Now you can, these down here, depending on the model, some of them are rated for 200, some of them are rated for 250. You can use either or, it doesn't really matter. If you have the 250s, use those. If you got the 200s will work fine too. I don't know what I have yet. What I do know is that all the caps are in, and I'll give it another look over in a minute. Let's see if my tip will... it actually will. It'll fit over these. So, make sure it's drained. Let's measure one of these. I just shorted that on my tweezers because I knew it didn't have a lot of juice in it, but I don't want to hook it up to my meter if it's got anything in it because it'll whack out the meter. So these are good. But sometimes they're not, so. And let's see what are the two or two. These are 250s. The MKII, I believe, uses 250s. The Super Juniors and the Architecturals use 200s. And they're 47 micro. So I have I have 200s. You can't go backwards. You can go up. 47, 250, 250, 250s. So I have two different styles. I have a UVYs, which are decent capacitors, and I have the larger UPS. I'm going to try and fit the UPSs in there because I think they're better caps. If I can't get them to fit, I'll put the UVYs in. And they're not going to fit because the lead spacing's off anyways. So I will go with the UVYs. Still a good cap. I just prefer the UPS. But UPS ones don't come in certain sizes. So you gotta pick and choose. But let's see, these are T-POM 85C rated, so I believe that, yeah, the UVYs are 105C. So better cap. Definitely a better cap. Alright, that guy's in. One more. And I think I'm going to fire it up. I'll fire it up before I replace these. And I'll go into a speaker first. I want to hear it. I want to listen to it. You guys won't be able to hear it. At least I don't think you will. I've never really paid attention or checked. This is a hard one to get to. But I'll put it into a speaker, listen to it. I want to make sure that it sounds okay, no hum, no distortion. Then I'll feed it into my dummy speaker, and we'll put the little scope on it. I'm not digging the big scope out now. buried underneath my shelf here. Oh, there we go. Alright, I'm back. Sorry about that. I needed to get some Q-tips. I was out. Luckily the wife has a stash with all of her makeup crap, so not too hard to get some. So I'm gonna clean the bottom of the caps off just in case, you know, there's that little bit of residues on there. It wasn't a lot. I mean, you won't even be able to see it on the camera. Let's zoom in. I haven't zoomed in at all this video. Let's zoom in and see if I can show you guys what leaking cap juice looks like. And yeah, I guess you can see it a little bit. There's just like a little hazy goop on there. Yeah, you can see it right there. But eventually, that goop will eat through the traces on the board, and it'll make your solder connections bad. So, a little isopropyl, and you can see it's already eaten into the board. That haze that's on there is permanent now underneath the fluid. So, yeah, we're going to go through and as best we can hit that with the alcohol. Don't use the same Q-tip twice on that junk either. Grab a new Q-tip or a new swab or whatever you're using. Try not to spill your alcohol all over the place, especially if it's good alcohol. Just get in there and give it a clean. Dry it off, and you're good to go. That's what happens when cheap caps get too hot. They squirt all their fluid out and wreck your boards. And you know, if those caps were to leak more, I mean, it will cause a significant amount of damage to the board. I mean, it'll burn through holes out, it'll eat through traces, it'll cause shorts. It's just not worth it. Take the extra time, clean it off. You will be much happier you did so. Alright, solder back in. Get the light out of the way. Zoom out, because we're way zoomed in. And I hit the darn button and I'm all out of whack there. Alright. So, we have board recapped, input and amp. We have cleaned off any of the corrosion. We found that we definitely had some bad caps on the system. I think we are ready for a test. Now I am going to leave the speaker. Actually, no, I'm going to hook the speakers up. Let's hook them up. I'm just going into a 10-inch Tang band speaker out of a Logitech subwoofer. That's my preferred test driver because I have a bunch of them and they're cheap, and if I burn them up or blow them up, I don't care. I'm going to face the board away from me. You can see our lovely pile of garbage caps here. I am going to make sure that there is nothing that can short this board out. That little sliver of solder is still there. Get that out of the way. Not that it would hurt nothing, but just to be a little overly protective. Make sure our power is off. Our volumes are all at 0. Everything's at min and 0. let's go in for the test. I can shut off my irons now. I don't need those right this minute. Alright. I'm just going to leave it like this. The standby light is down here. You guys should be able to see it go red when I turn it on. We're going current limited first. We're also going to make sure that our speaker wires are not shorted. I really need to put some insulated terminals on that. Alright, here we go. Current limit. Power on. Got my little flash of the light bulb. We have power. You can see we're in, we should be in standby right now. I am going to give it 30 hertz. I don't know if that came alive or not, but I'm going to give it a little volume. Alright, LED went bright, which means that our standby circuit is working, and I have 30 hertz. I can't crank it up because A, it'll totally destroy the speaker, and B, my wife is sleeping literally 8 feet above me. I will get murdered on live broadcasting. Sounds good. I am going to turn the volume down, take the inputs away, turn the volume up, and I'm listening for hum. No hum. Dead silent. That's the way it should be. Give it a little volume, going back to too much. Back to 30 hertz input. And now I'm going to kill the power while it's driving the speaker. I've noticed that when you turn these amps off, they do something. I don't know what the heck happens, but the woofer just goes almost all the way out and then sucks back in. If you have a little bit of volume on there, it tends to make that a little bit less. So that's my my fix for not killing my speakers when I'm doing that. Alright, so now I am gonna take my power's off. I'm gonna take my speaker out, and I'm gonna switch over to my dummy load. Yeah, damn, I definitely spilled water back here. Knock that. And I knocked my little vial over. Just a few drops, nothing major. Just enough to be annoying. Alright, I have my dummy speaker. I gotta clean this dust too. This desk is a mess. We're gonna go 4 ohm load. Which should put a nice nice stress on this amp. I'm not going to crank it all the way up. I'm just going to do, you know, a nice small 4 ohm load, or I'm sorry, a nice low volume load into 4 ohms. And we're going to look at the output on the scope, see what it looks like. So I'm going to grab my little cheap scope, my battery modified Quimot. That's ultra portable. I already have these leads hardwired into my dummy load, so I can fire this guy on. Let's move. Move my amp back a little bit. Give this guy some room so you guys can see what the heck is going on. Alright. Power up my scope. And I'm going to zoom in on this guy too. Of course it zooms in right where... Alright, we can see it there. Right? I can see it there. if it'll focus. Let's get rid of the ambient light. I don't know if I'll be able to get the camera to focus better than that. Let me try manual focus real quick. Give me a second. Camera settings and control. I don't think I'm any better than the autofocus. Alright, well, that's as good as it's going to get, unfortunately. But that's alright. Alright, so here's what we're going to do. We got 30 hertz going in. We're going to go current limited power on. Alright. And even with that low amount of volume, you could see I was almost at current limit. So I'm just checking to make sure that, you know, we're actually getting output. Now I'm going to switch over to full power. No more current limit, and I can actually turn the volume up. So you can see the sine wave, even on this cheap scope, the sine wave is nice and clean. There's no distortion. It's showing, and I know this is really hard to read. Let's see if I can zoom in just a little bit more. And try playing with the focus just a tad. Well, it's hard to read, but you can see it's bouncing between 30.01 and 29 and change for the frequency. So we're getting a nice clean 30 hertz out. The wave looks really good. And you know, these little cheap scopes for audio testing are perfectly fine. I mean, we're looking at a subwoofer signal here, and subwoofers are mostly noise anyway, so you don't need to have, you know, a super good scope to troubleshoot. So I'm going to turn the frequency up. So now we're at 35, 40, and you're going to see 50. We're going to start losing volume, and that's because we're starting to hit the crossover frequency. So what I'm going to do is I'm going to take the crossover knob and turn that all the way up, and then give it a little more volume. So we're at 53 hertz. I'm showing 59 on mine. If I speed my time up so I get a better waveform on there, it'll get a little more accurate. Now I'm showing 53.7. And again, you can see that the waveform is nice. I'm not getting any peaks, any spikes. It's a nice, clean sine wave. Stretch it out a little bit. I can give it a little more amplitude on the amp. I'm sorry, that was phase, not volume. I can give it a little more volume there. We can look at it. And you'll see there's a little bit of garble at the bottom down here. That's this. It's not the amp. And it's also because we're running into a resistor load instead of a speaker. So it behaves a little bit differently. Let's keep going. We'll sweep it up to 100 hertz. There's 60, 70, 77, 80, 90, 94, 98. There's 100 hertz. And I'm going to speed up our time a little bit. Now, you know, we're still losing amplitude, so I got to turn the volume up a little more to get some of that back. And again, that's because you're hitting the roll off that's like into the crossover on the amp. So 100 hertz, it still looks really good. Dial that back down. You'll see as I go down that it's going to get louder, which makes sense. And I'm still at pretty low volume levels, but going through a speaker, this would be pretty loud. So I'm going to adjust that as this rises just to keep it on the screen. So go to 40, 20, 19, 17, 15, even at 15 hertz. You know, so these subs can get pretty low. The amps did 13, 12, 10. You know, I'm getting. I gotta speed up my time a little bit, but we're getting output at 10 hertz, and I'm showing I'm getting 10 hertz. So these amps can definitely go pretty low. But my 300 watt load is getting a little bit warm, so we know it's putting out some power. I do most of my testing at 30 hertz. That seems to be the sweet spot for where most of the listening range for these will happen. And I'm maxed out on my voltage on here. We're at 20 volts. We're showing 45 max on my peak, so I'm maxed out on my little meter. I think the most it'll do is 50, and my volume is at maybe 6%. So this is a pretty stout amp. This thing's gonna put out some juice. But the only thing left to do on this is the main filter caps. But I think we have a successful repair. It was, you know, basically a simple recap, but during that recap we did find numerous caps that were defective on there. I'm not going to go through the replacement of the main caps. I'm just going to explain it, because I'm going to take a coffee break first. Volume's down. I'm going current limit off. My resistors are scorching hot. Current limit off is going to kill the power. Take our audio leads out. Pull our plug out of the wall. So you can see we have a successful repair. We're back in business. We could stop there. I believe it would have a fairly long service life without doing any other changes. Since this is the second amp I'm working on for this guy, I'm going to go ahead and replace the main caps in there. I have them, so I'm just going to do it. But now this is still live here, and this is something everybody needs to pay attention to. So this has been unplugged. It had a load into it. We turned the power off. The load should have been bled off by, you know, anything going out of the woofer, but let's just see what we have left inside these caps. 156 volts. That's a lot of juice to be messing around with. So we got 156 there. And let's see what we have on our output caps. So our output caps are bled down because we had our speaker connected. That's down to 6 and change. But our mains are still holding some juice. And these mains over here still might be holding some juice too in the film caps. So I'm going to bleed them off. Show you how I do it. So I just took 2 old meter probes off of a cheap meter. I forgot to turn autofocus back on. Sorry about that. There we go. The other end of these is hooked to a light bulb. It's back behind my bench, and I just go to the bridge and drain it. And these 2 are now drained. If you go across the, I mean, you could do the whole bridge too. You can hit all sides. Make sure you drain each one individually. But this is the main positive and negative. So if you go here, you're going to take the whole thing down. Now these are safe to work on. 156 volts. I mean, I've gotten nailed with 220 before. It's not fun. But all right. So yeah, I'm not going to do this on camera just because it's tedious work and I want to take a little bit of a break. But these are point to point. So I use my solder sucker and I get in here. Let me zoom in. I use the solder sucker and I get in here and I suck off as much of the solder as I can out of here. And then I take my iron and I get it behind the wires and I just pry them off the cap. And I do one set of wires at a time just because they're not color coordinated and it's kind of weird how they have it set up. But I get those off and then I just put them onto the new cap and solder them in place, and I do one at a time. These original caps had really long legs from the factory. The replacement Nichicon ones are not nearly as long. So sometimes you have to get a little creative with how you wrap the wires just to make sure that you can get them on there. Make sure your polarities are correct. You don't want the polarity on these to be backwards. One, because these caps are expensive, and two, you don't want the cap to freaking fill your house with smoke. So it's not too hard to do. It's just tedious because it's point-to-point wiring. Again, if you're doing your own amp and you're repairing at home, you can probably leave these guys alone and you don't really have to do it. But that's basically about it. Whole MK2 redone and recapped. I have a couple more of these to do. Hopefully some of them will have some different issues with them other than just some bad caps. I have gotten into replacing the outputs before. These 4 outputs, that's always interesting. If you don't know what blew the outputs, sometimes you have to replace them twice, and those aren't cheap. The regulating MOSFETs for the power supply, I've replaced those before. I'll go through that. I know I have one amp that needs those done. So, like and subscribe, and be sure to check back for some of my future videos, and I'll try and cover all these different things that I know go bad with these amps. Everyone is a little bit different. Everyone has its own set of problems and things that are wrong with it. So, it is repetitive with doing a lot of the work, but solving the actual problem of what's wrong with each specific amp is usually a little bit different. So, I hope you guys come back. I hope you like the videos. Feel free to ask me any questions you want or post some comments in the comment section below. And I will see you guys for the next video. Thanks for tuning in, and have a good night.